So part 2 of our parametric equations section is about more complicated equations and eliminating the parameters of these. So some of them are going to be involving trig, and when we have trig, we need to remember our two of our identities, sine squared plus cosine squared is equal to 1, and that secant squared minus tangent squared is equal to 1. And we need to isolate the trig functions first. So we're going to be dealing with, isolate both of them for the trig function and then use an identity. And we'll talk more about that when we get there. So example 1a, we have x equals t to the 6th power and y equals 6 ln of t. Well, we can't get t by itself in the top equation, because if we take the 6th root, we're going to have plus and minus because it's an even root, and again, that just makes things more complicated. So instead, we will work with the ln, 6 ln of t. So that changes to 6 times log base e of t. Divide both sides by 6. We have y over 6 equals log base e of t. And then we can switch it to exponent form. So that's going to be e to the y over 6 equals t. So now I'm going to take that and substitute it for t in the x equation. So x is equal to e to the y over 6 power raised to the 6th power. Well, remember, we have a power raised to a power, so we can multiply them. So e to the 6y over 6, which is going to be e to the y power. So then that would be our final answer when we eliminate the parameter x equals e to the y power. Now, it didn't say anything that we had to solve for y or x, so that can be our final answer. Now with letter B, we have x equals 1 over the square root of t plus 1 and y equals t over t plus 1. Both of them are not ideal to deal with, but we can work maybe with the x one because there's only one t. And the y one, there's a t in the numerator and denominator. So if we look at the x equation and multiply both sides by the square root of t plus 1, that will give us x times the square root of t plus 1 equals 1. Now we have to get t by itself, so we can divide both sides by x. So the square root of t plus 1 equals 1 over x. Square both sides. And when we square both sides, we get t plus 1 equals 1 over x squared. Well, now our last step will be to subtract 1 from both sides, so t is equal to 1 over x squared minus 1. So now we can take that and substitute it in for both t's and y. So yeah, this is going to get a little ugly. All right, so we have y equals t, which is 1 over x squared minus 1, over t, 1 over x squared minus 1, plus 1. Well, the minus 1 and plus 1 are going to cancel. So we have 1 over x squared minus 1 over 1 over x squared. Now we can multiply the top and bottom by x squared over 1, or just x squared, because now when I distribute this up here, the x squareds will cancel from that one, and we're left with 1 minus x squared over, well, in the denominator, the x squared and x squared will cancel, so we're left with 1. So that's as far as we can take it, so y is equal to 1 minus x squared over 1. And then that will simplify to 1 minus x squared. Now, it is important to note that your domain, x has to be bigger than 0, because in our original, we had x in the denominator right here, x in the denominator, x in the denominator. So we do need to say x has to be greater than 0 for that. So those were a little bit more complicated than the ones yesterday. Now, again, for these trig ones, you see these last four have sine, cosine, secant, and tangent. We need to get the trig function by itself in both of them. So for x, we have x minus equals -3 plus 5 times the secant of 2t. So we subtract or add 3 to both sides. X plus 3 equals 5 secant of 2t. And then when we divide by 5, we get the secant of 2t equals x plus 3 over 5. And then for the y equals 2 plus 4 times the tangent of 2t. Y minus 2 equals 4 times the tangent of 2t. And then when we divide by 4, we get the tangent of 2t is equal to y minus 2 over 4. Okay, so now we have our trig functions by themselves, and we know that secant squared minus tangent squared is equal to 1. So I'm going to take secant squared. If I'm here, I take secant squared. I'm just going to square both sides, but I'm going to use this x plus 3 over 5 squared minus, go over to the tangent one, square both sides there. So y minus 2 over 4 squared equals 1. You may say, well, why did we have to do that? Remember, the directions are to write it in rectangular form. Well, rectangular form is x and y's in it. We have secants and tangents. So we have to use that identity to convert it to rectangular form. Now we can square the top and bottom. So it's going to become x plus 3 squared over 25 minus y minus 2 squared over 4 equals 1. And oh my gosh, that's a hyperbola. We know it's hyperbola because we have x squared minus y squared. So this would be this parametric equation is a hyperbola in disguise. All right, now this one, we have sines and cosines, so we'll get the trig functions by itself. Add 2 to both sides. X plus 2 equals 2 times the cosine of theta, and then divide by 2. So the cosine of theta is equal to x plus 2 over 2. Then with our y equals 4 sine theta, well, that one's easy. Just divide both sides by 4. Sine of theta is equal to y over 4. Well, our identity for sine and cosine is that sine squared plus cosine squared is equal to 1. So if I square this, I get x plus 2 squared over 4. So then with the sine, square both of them. So we have plus y squared over 16 equals 1. So this is an ellipse that is vertical because a bigger number is under y squared. So again, this parametric equation up here is this ellipse in disguise. All right, letter E, very similar to the one we just did. So x equals 2 cosine of 2t. Divide both sides by 2. So the cosine of 2t is equal to x over 2. And then y equals 4 plus 3 sine of 2t. Y minus 4 equals 3 sine of 2t. Divide both sides by 3. Sine of 2t is equal to y minus 4 over 3. Now, you might notice a difference with this one. It says cosine of 2t and sine of 2t. This one is just theta. It doesn't matter as long as the angles are exactly matching. And for us, they always will. We have cosine of 2t, sine of 2t. We can still use that identity where cosine squared plus sine squared equals 1. So if we square both sides here, we get x squared over 4 plus square both sides here, y minus 4 squared over 9 equals 1. So this is another ellipse that is vertical because the bigger number is under y. All right, now the last one. Now these at first probably looked like they would be more difficult than maybe these up here are the ones we did yesterday. But I hope you're seeing that these aren't really that bad as long as you use these identities up here. So there we have x equals 2 times tangent of t. So x equals 2 times tangent of t. Divide both sides by 2. Tangent of t equals x over 2. And then with secant, y equals 3 secant of t. Divide both sides by 3. We get the secant of t is equal to y over 3. Now, with the sine and cosine, because we were adding, it didn't matter what our what order we went in. Here I put the x first. I put the x first here too. But the order didn't matter because we were adding. But for this, secant squared and tangent squared, secant squared must go first because it's secant squared minus tangent squared, and order matters in subtraction. So square both sides here. So we have y squared over 9 minus square the tangent, x squared over 4, and it's going to equal 1. So this is a hyperbola that is vertical because the y is positive and the x is negative. So again, it's not too bad as long as you remember to use those identities at that point. So at the next page, it says find the parametric equation for the hyperbola with vertices at 0, plus or minus 2 and foci at 0 plus or minus 4. And I give you the hints here, the parametric equation of a vertical hyperbola and then the parametric equation of a horizontal one, and they're there. And you'll notice that you need the h, k, a, and b values. The same thing that we needed before when we wrote them from this information. So we're going to do the exact same process here that we did previously, and that's draw a sketch. Vertices at 0 plus or minus 2, so 0, 2, and 0, negative 2. That tells us that this is a vertical hyperbola. So this is the one that we're going to be using. All right. And then our center, our h and k, is going to be exactly halfway through, which is going to be at 0, 0. Oh, that's nice. hk is at 0, 0. Then our foci are at 0 plus or minus 4. So remember, our a value is the distance between the center and the vertices. So a is equal to 2, which means a squared is equal to 4. And our c value is the distance between the vertices and the foci. So, c equals 4, which means c squared is 16. All right, in a hyperbola, c squared is equal to a squared plus b squared. So b squared is going to be 12. Now look at our equation that I circled up in green. We don't need b squared. We need what b is equal to. So we need to square root both sides and then write it in simplified radical form. So b is the square root of 12, which is 2 root 3. So that's our b value. We have our a value. We have our h and k. So we can write our two parametric equations. So x equals h, which is 0, plus b, which is 2 root 3 times the tangent of theta, which 0 plus anything doesn't change. It doesn't change it. So x is going to be 2 root 3 times the tangent of theta. Now y is equal to k, which is 0, plus a, which is 2, times the secant of theta. And again, 0 plus anything is just going to not change anything. So our two parametric equations are these two. All right, so again, these trig ones they look a lot harder than they actually are. So thanks for watching. Make sure to like the video and subscribe.